My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 124. In this lecture, we will try to understand relationship between mean of Poisson distribution and mean of exponential distribution. After this, we will try to solve one simple problem on exponential distribution with the Python programming language. Now, because the average number of arrivals, just to understand this point, let me repeat, because the average number of arrivals is 10 cars per hour. So the average time between cars arriving is this mean is taken for Poisson distribution. That's what it says, isn't it? 1 by 10 is mean for exponential distribution. That means time between arrivals is 1 by 10. That's you must understand. Time between arrivals is 1 by 10. So that the relation between, I can simply generalize this relation like this. Mu is, what is mu? Mu is mean for Poisson distribution. Mean for Poisson distribution, isn't it? Poisson distribution. Whereas 1 by mu is mean of, or mean for exponential distribution. Exponential distribution. This relation is very, very important. Just understand this relation. That's why we used to say lambda equal to 1 by mu. That lambda is mean for your uniform exponential distribution, isn't it? Yes. Anyway, just this is golden point, isn't it? What is mu? Mu is mean for Poisson distribution. 1 by mu is mean for exponential distribution. This is the relation. This is the relation. This is the relation between mean of Poisson distribution. Relation between mean of Poisson distribution and mean of exponential distribution. Let me say ED, just for simplicity I am saying, isn't it? Just try to understand this relation here, because the average number of cars arrival in 10 cars per hour, this 10 is, what is this? Mu, isn't it? In lecture number, I think 122 also, we discussed relation between Poisson and exponential distribution. Just refer that lecture once. Whereas 1 by 10 is mean for your exponential distribution. We will try to solve one simple problem with the help of Jupyter Notebook. Just see this problem. What it says: a manufacturing firm has, let me say like this, example on exponential distribution, like this. Here, first let me read this problem. A manufacturing firm has been involved in statistical quality control for several years. As a part of the production process, parts are randomly selected and tested. From the records of these tests, it has been established that defective part occurs in a pattern that is Poisson distribution. It is following Poisson distribution on the average of 1.38. Means Poisson distribution average mu equal to 1.38. This is, you must understand, this is Poisson distribution, isn't it? Poisson distribution. This is Poisson distribution. But I need exponential distribution mean. How can I calculate exponential distribution mean? 1 by mu is the mean for exponential distribution, that is 1 by 1.38. This is exponential distribution mean, isn't it? That's what I discussed. Therefore, MUL is a variable in which I am keeping 1.38. Yes, I will read. Let me read this one again. It has been established that defective part occurs in a pattern that Poisson distribution on that average 1.38 defects per 20 for every 20 minutes during the production runs. Use this information to determine the probability that less than 15 minutes, I need probability less than 15 minutes will elapse between any two defectives. That is, this between word is very important, isn't it? Here we have to look at the two things in the problem. One is mean of your Poisson distribution, that is 1.38, and the second thing is between any two defects. This point is important, between any two defects. Whenever the word between two things, whenever between two things, you have to go for exponential distribution. How do you know whether exponential distribution is applicable or not? Here in the problem itself, there is a word between any two defects, means it must comes under your exponential distribution. First, we will find the mean of the exponential distribution. I already discussed how to find mean of the exponential distribution from Poisson distribution, that is 1 by mu. So the mean of an exponential distribution is 1 by mean of the Poisson distribution. Poisson distribution mean is 1.38, therefore 1 by 1. This can be represented lambda equal to 1 by 1.38, I can say, isn't it? That's 1 by this. If you calculate this value, you will get something like 0.72 some 4637 you will get. Anyway, we will try to understand. What was asked? Probability less than 15 minutes. That's my question. Probability less than, from SciPy dot start, import expon. Expon is an object. You have to find out cumulative probability. Why? Because less than means I need cumulative distribution function. Therefore, there is a function in expon object, expon dot CDF, cumulative distribution function. Anyway, we will try to understand. So 0.75%, this is 0.75 represents, because we got 0.75. How will you get this 0.75? 15 by 20. 15 by 20 is 0.75. What is 15? What is 20? This is less than 15 minutes, but your mu is defined for 1.38 for every 20 minutes, isn't it? This is for every 20 minutes, this is for 15 minutes. Means there is a mismatch, because mean was in the Poisson distribution, mean was for 20 minutes, isn't it? Mean was for 20 minutes. Now the problem for the exponential distribution asked for 15 minutes, isn't it? Question is asked for 15 minutes, but your mean is for every 20 minutes. Means there is a mismatch for, isn't it? We are so that in order to match, we are dividing 15 by 20 so that the units are matching, so that you can match the units. So we need to find out cumulative function or cumulative distribution function of exponential distribution. The lower limit of that x is 0. I already discussed in previous lecture. Your x starts at 0. Your upper limits 15 by 20 is 0.75. So expon dot CDF upper limit 0.75. I can write like this. How can I write? From we already know this one, from SciPy dot stats, from SciPy dot stats import expon. What is my import expon? What is my expon? Expon is an object which represent exponential distribution. Expon dot CDF. I need cumulative distribution function. This is 0.75. How do you know this one? For less than 15 minutes, means in order to match that one, it is something like this. For 20 minutes you calculated, but how far I need for 15 minutes, means elementary maths, that is 15 by 20, that is 0.75, isn't it? 0.75 comma my lambda is 1 by 1.38. These are the arguments for my cumulative distribution function. Once if you execute this piece of code, you can understand, you will get probability that is less than 15 minutes will elapse between any two defects. As it is between, I am using exponential distribution less than 15 minutes, as there is a mismatch for your mu and less than 15 minutes. In order to match, just I am dividing 15 by 20, that is 0.75. that is first argument for your cumulative distribution function. Now we will try to understand just that's simple explanation. Just run this piece of code, what happens, you are getting that's what we are saying. This is my lambda, this is my 1 by mu, this is 0.75 is my first argument, 1 by 1.38 is my second argument. Therefore what I need probability less than 15 minutes will elapse between any two defects is 0.2504337. This is my probability, isn't it? This is a simple problem, anybody can understand. Just go through these points. If you have any difficulty, just keep a comment so that we will try to understand. Thank you very much.